On This Week in Enterprise Tech, is Skype listening to your calls? Is Cisco supersizing the core? And what is the future of Wi-Fi? Coming up, Twice on the Set.
Netcasts you love.
From people you trust.
This is Twit.
Bandwidth for This Week in Enterprise Tech is provided by CacheFly at CacheFly.com.
This is Twice. This Week in Enterprise Tech, episode 48, recorded July 1st, 2013, 8:02:11 AC. This Week in Enterprise Tech is brought to you by TechServe. TechServe assists U.S. businesses of all sizes with their technology needs, including Apple, Avid, Adobe, and HP solutions. Visit techserve.com/twiet and receive a complimentary iPad deployment assessment. And by MailRoute. MailRoute is email filtering in the cloud for companies of any size. If your service is disappearing, talk to MailRoute for price matching on Postini or Forefront contracts. Visit mailroute.net/signup.html and use the promo code Enterprise7. Welcome to Twice, This Week in Enterprise Tech. It's the show dedicated to the enterprise professional, the IT pro, and the geek who just wants to know how the world is connected. I'm your host, Father Robert Ballasare, the Digital Jesuit, your guide to all things in the enterprise. And as always, I am joined by an all-star panel, starting with my good friend and the geek in paradise, Mr. Brian Chi, the evangelist for Thin Links. Brian, you're back in Honolulu. Tell me, is the weather over there as bad as it is over here?
It's rainy, but it's not too bad. But I will say, it doesn't matter, because for the next 2 days, I'm going to be only in the lab. I've actually got 6 airmen coming in from the Hawaii Air National Guard, and we are going to empty the black hole and clean it up and get this place presentable, because we're going to be dedicating a cyber range. Think of a gunnery range, but for cyber warfare. And we're going to be hosting in the first week of August a competition where blue team versus red team get to go and take pot shots at each other in cyberspace. It ought to be awesome.
I think what we have to do is we have to get you down to DEF CON and bring your toys with you just to see how they fare against, we'll just say, hackers in the wild. But that's good news. Hopefully we can get some of that on Twice. Now, I am also joined by a super special guest here, Mr. Hans Osnabrücker, who is the CEO of Ringcredible. Hans, thank you very much for coming on. Can you tell the Twice Riot, that's what we call our listeners, just a little bit about yourself? You've got a long list of accomplishments, and you've been involved in VoIP for a very long time. Tell us how that came to be.
Thanks for having me, Padre. I joined the VoIP community, I think, about 5 to 10 years ago. And the last 3 years, we started working on developing Ringcredible. And we saw that a lot of VoIP applications were using the Skype model, so the closed user group, and all the other apps did the same thing. And the good thing we thought about Skype out, that only one side had to be online, and the one you could call just anyone for just a few cents. I think that our geek community already knows, of course, about that for 10 or 15 years. But the whole bunch of people outside there in the whole wide world, 99% of them don't have a clue that you can call anyone for just a few cents when you're online. And when now everyone has a smartphone or a tablet, for us that was the moment to gear up. And now we're speeding way front ahead with Ringcredible in not only within the Netherlands where we started, but also starting our first steps within the US and Canada. So we're having fun.
Yeah. Now, we brought you on specifically to talk about some of the issues with Skype in light of the disclosures about the NSA spying program. But I want to back up a bit for a second and do talk about the adoption of VoIP. Because, I mean, as a geek, I've been using VoIP for a decade, more than a decade now. It's just one of those things that's part of my regular arsenal of tools whenever I'm doing a telecom project at one of our locations. But I think you're right in that there's still a large part of the population that doesn't really understand VoIP, doesn't understand Skype, doesn't see it as a real credible alternative. Why do you think that is?
I think that one of the main reasons for is that a lot of people, for us, we can't even understand that, but a lot of people still don't trust the internet completely. And for a lot of people, only the last 2 to 3 years got known with real VoIP applications on smartphones and tablets. So a lot of people are new to this. So I think that's one of the main reasons for that, and also the usability when Skype and alternatives started on the computer. Then I think that it was still a lot for techies and people like that. And now the larger and larger community starts to get acquainted more with Skype and alternatives. But I think it really took some time before the large consumer base started to know what's possible. And I think that's one of the main reasons they're now as shocked as the most people are.
Right. Cheevert, I want to throw over to you for a second. Y Guy in the chat room brings up a good point. He wonders if this aversion to VoIP is because a lot of people still don't understand how it works. We've been using VoIP in the enterprise for a long time. Every system we've ever set up for interrupt uses some sort of VoIP project, even if it's been slightly changed in order to meet the demands of a particular vendor. But we've seen more and more that people are using VoIP even if they don't know they're using VoIP, right?
Yeah, a lot of times, well, like for instance, back in the late 60s, early 70s, I was a clerk typist for the AlohaNet project. And we actually proposed that VoIP be used for moving voice calls around. Instead of having these dedicated copper lines, that we use data lines to move large amounts of voice. But, you know, a lot of people don't realize that nearly 100% of the long distance calls, especially in North America, hit VoIP trunks in one form or another. So you are using it, you just don't realize you're using it, and gee, why aren't you using it more?
Right. Hans, let me go back over to you because we do want to talk about Skype. Skype hit the limelight recently because there were a few revelations about the kind of protection you are and are not getting from Skype. Now, let's back up a couple of years. Back before Microsoft bought Skype, it was a real geek project. You had supernodes. So essentially, you had users' computers that had enough bandwidth that were used to route calls, VoIP calls from one user to another. It was more or less secure because there was very little central control. What has changed about Skype in the last couple of years that has, well, let's just say changed the structure of how Skype works?
I think you exactly hit the right point within that. When Microsoft took over, Skype stopped being that decentralized organization, and it all centralized to the Microsoft servers. And I think they started with that, I think about 2.5 years ago. And with that, of course, from a Microsoft perspective, it gains much more control. And that's good for a lot of reasons. But yeah, I think with the Prism scandal, we also see the other side of that. And that's I think the step that when Skype was started when they were young and eager and helping the world, to a large corporation with now embedded within Microsoft. This changes the rule of the game.
Right. Yeah, because once you started centralizing servers, and I believe the last time I read up on it, Microsoft has 10,000 Linux servers that they're hosting at their data centers across the world, actually. And those have replaced the supernodes, which theoretically could give Skype more consistency, although we're not seeing that a lot. But it also means that with centralized control, you have the ability to do centralized monitoring, centralized tapping, and dare I say it, centralized spying. Let's talk specifically about something that's not voice, and that is contact information. One of the points that I saw listed in an article that you were recently referenced in was that Microsoft is storing your contact information, your phone numbers, and any information you may put into Skype in the cloud. What are the ramifications of doing that?
I think one of the problems, of course, with that is the security. I think that Microsoft and Skype are well capable of doing a very good job of security. But still, also for your the privacy side of that, if you want to offer closed user group calls like Skype does, you need to store that data on their servers. And yeah, of course, next to the risks of hacking and stuff like that, of course, I think one of the most important reasons is privacy. They know an awful lot of you.
Right, right. Cheever, we've talked about this quite a bit. Putting your data in either a public or private cloud can do for your security. What is your level of comfortability with putting sensitive data in the cloud?
NSA, can I get a restore from my backup from 10 years ago? You know, the reality is why? Who cares? You know, I'm storing almost 3,000 contacts on my phone, and T-Mobile can harvest that through their web interface. So at this point, who cares? You know, it'd be nice if they could get me my restores, but I'm sharing my contacts with an awful lot of people. And the only time it starts bothering me is if I've got some unlisted phone numbers in there. I'd kind of like them to stay unlisted. But, you know, heck, I'm even listed in the phone book. So, yeah, maybe I don't care as much as a lot of other folks. The only thing I really didn't like was when I worked at Xerox and the salespeople would call me on Sunday nights and say, could you check over my proposals for Monday morning? It's like, yeah, this is getting really old, guys.
Right, right. Hans, let me go back over to you. Another point that you brought up in the article that referenced your work was how you have become untrusting of Skype as an ad-supported platform. Why is it? What is it about Skype being ad-supported rubs you the wrong way?
I think the issue is not only that ads interrupt user experience, but ads mean that a company will be held captive to ad networks or brands that will want and need the user's data. And this is where much heavier tracking comes in. And in this moment, and the company can hold your demographic, your location, your list of interests, and your browsing habits. And I think like Brian says, okay, of course you can say, hey, who cares? And but I think if everyone knows that's the fact, then there isn't a big problem. I think why the fuss is all about is that a lot of people do not have a single clue that this thing is happening. And especially that whole bunch of consumers that just entered this century of smartphones and tablets and don't have a clue what's happening with their privacy. So I think that's probably the main issue. Not only that it happens, but that the people do not know that it happens. That's probably the big shock.
Yeah. I think that's a fair point. Essentially to say, look, people have been surrendering personal information to corporations for quite a while now. That happens every time you go on Facebook, Google, whatever it might be. But we are much more likely to do that when we're actually being told what's happening. We want companies to be honest with us. We want our government to be honest with us. We definitely want Microsoft to be honest with us if we're using Skype. Okay, now let's get into the meat of the matter, because we've been talking about putting information up in the cloud. We've been talking about them mining our advertising habits in order to sell us advertising on Skype. But there is another issue that specifically relates to the NSA spying program, and that is that Microsoft actually uses Smart Screen in their versions of Skype. Now, people who don't know Smart Screen scans through everything that's put into the instant messaging, into the SMS. It's supposed to be to stop spam. It's supposed to be to stop malicious links, but it means that they're looking at everything that you type into that box, which means it's also logged, which means that if, depending on how much you trust them, that could be a bad thing. Now, Hans, let me ask you about this. We found out all about this from the Ars Technica article that talks specifically about smart screen, about how it was used. They ran an experiment, actually a pretty good one, where they set up a web server that had two links. One was HTTP, one was HTTPS. They sent those links through an instant messaging box on Skype from one client to another. They never clicked on the link, but then they started noticing activity. When they tracked that IP address back, it turned out to belong to a range of IP addresses that belong to Microsoft, which seems to indicate that Microsoft is going to each of these sites, if you believe them, just to check to make sure that they're not attack sites, they're not phishing sites. What's the problem with that? What do you see as being the big breach of privacy, the big breach of security?
Again, I think it's the same issue that the smart screen technology is very good, and even you could say important for a closed user a solution like Skype. But also here you see that they have the technology to make sure they can spy on every way that's necessary. And then you as a user, you just have to trust that a Microsoft manager doesn't think, hey, I want to check this or I want to check that out. So the technology is there, and Microsoft can push every button, and you don't know if they do that or not.
Right. Chibert, let me throw this over to you, because we've talked about this in private. We've talked about this over drinks. We've talked about this when we were drunk, and actually I think that's the best conversation we've ever had. But specifically about network monitoring, both of us are in that business. I mean, we set up network monitoring. We can't have an enterprise-class network without looking at the traffic that goes through the network. The question really then becomes, do people trust us to do the right thing with the data that we get? Do we log it? Do we screen it? Or do we capture it and look at it later on? Are we diligent in following our own best practices in protecting our user security? Do you think that with the revelations about the NSA spying program, that could be, as someone in the chat room mentioned, the spark, the match strike that finally gets the regular person interested in encryption?
I think it's, I think I can draw an analogy. It's kind of like, back in the 90s, we had a big discussion because Newsweek magazine, an actual paper magazine, started customizing various issues. They actually had a version that was specific for doctors. They had another one specific for dentists. They had one that was actually specific to architecture. There was actually a big brouhaha about that because they said, "Oh, this is all kinds of privacy issues. You know, you're customizing your ads to us." It's like, yeah, because people want to make money. I think the spark about this whole thing is that it's causing the general public to become more aware of what's going on, that marketing isn't necessarily bad, but it's also not necessarily good. A lot of it is determined by what the people, what the viewers, what the consumers want to say. Remember how I keep saying you vote with your dollars? Having the trust that someone's going to do the right thing is trust but verify, I think, is probably a better term. The consumer needs to verify that they are doing what they're doing in your benefit. And if it's not, you need to scream. You need to vote with your dollars. You need to do things like Paula Deen getting removed from the Food Network and all of a sudden her fans boycotting the Food Network. The same thing needs to happen with things like Skype or GT or the different things. You need, if they're monitoring and you don't like it, stop buying it. Who knows?
Yeah. Hans, we have on our network Mr. Steve Gibson, who is a security expert, and the phrase that he loves to say is trust no one. You have to act as if everyone is trying to get your information. And even if you don't think it's important, you still need to trust no one. You need to encrypt your data. You need to make it secure. It's your personal responsibility. Is that a philosophy that people should take, or is it still okay to say, I'm sure it'll be okay if I release this information into the wild?
Yeah, I think that's always a difficult one. But I think that when you use closed user groups like Skype, and you know that your voice recording or your messaging stays on their servers, then then you make that choice. It's not necessary to make that kind of choices. You have excellent alternatives for that, of course. But yeah, when you make that choice, you should know that. And when you want to be totally sure you're secure, then you have to be able to control both sides of the servers. And in a case like this, you don't. So yeah, I agree with Brian. Accept it. Accept it when you know it. I think that's the first step. So make sure you know what happens with your data, and then you can make a reasonable choice whether to use a solution like this or you choose other solutions that do not have those privacy problems.
To be the informed consumer or the informed IT administrator, I don't think there could be better advice than that. Hans, thank you very much for being on the show. Thank you very much for talking to us about what is still an emerging story. Every time we think we've seen the end of the NSA story, there's another twist, there's another turn, there's another company added into the mix. And so it's nice that we can talk about one of the products, one of the companies that's involved in this without getting hysterical. I think you brought up some very good points about how we need to act, how we need to see our privacy, and how we need to be informed. Now, I want to give you 60 seconds here. I know that you're the CEO of Ringcredible. Tell us why we would choose Ringcredible. Tell us why we would choose your service. Tell us a little bit about what you do.
Okay, thanks. With Ringcredible, only the one who makes the call has to be online. You can call anyone within the world, every landline, every mobile, for just a few cents. On average, we're 70 to 80% cheaper than Skype, cheaper than Vonage, Fungo, or whoever. And why? Because we don't store your data within the cloud. We just have a very simple model. We buy minutes from the largest parties in the world, from British Telecom, from AT&T, Verizon, and we sell them to you. And because we don't offer closed user groups like Skype and other parties do, that's why we have a very cost-efficient distribution model. So with us, it's the same usability as a normal call. You can call anyone in the world for just a few cents. So why set up a Skype meeting or make sure that your data is stored in the cloud if you can just call the normal way? And that's what we offer now at the Ringcredible. And we're growing very fast, and that's good to see.
Fantastic. That's Hans Osnabruja, the CEO of Ringcredible. Thank you again for being on This Week in Enterprise Tech. We wish you well, and we wish you happy VoIPing.
Thanks.
Now, coming right up, we're going to be talking about a couple of enterprise bytes that will affect the way that you use the internet. But before that, I want to take some time to talk about the first sponsor of the episode, and of course, that's TechServe. Now, we know that Apple's a big part of the enterprise. They're there. They're a huge company. They make great products. And honestly, we don't focus enough on them on This Week in Enterprise Tech, which is why I'm so happy that TechServe is part of the Twiat Riot. Now, as the largest Apple-based authorized reseller and technology provider in New York, TechServe serves creative professionals at all levels, from individual customers to Fortune 100 companies. They carry a full range of Apple products from iPhones and iPads to iMacs, MacBooks, iPods, and accessories. TechServe also has a range of partnerships with top vendors to facilitate flexible, efficient, and creative solutions for all of your business needs. TechServe assists businesses of all sizes to deploy Apple, Avid, and Adobe solutions throughout the United States, whether you're already committed to iPads or just getting started. From sales to support, process to practice, TechServe can help. Now, some amazing technology solutions are being deployed on iPads. You can see them on screen right now. If you've been to the Delta terminals in LaGuardia, Toronto, or Minneapolis, you may have noticed nearly every seat in the terminal is equipped with an iPad. Travelers can now sit anywhere in the terminal and receive real-time flight updates on the iPad, or use the iPad to order food, play games, browse the internet, and check email while they're waiting. Over 1.5 million visitors use these iPads in Delta's terminals just this past year, and the result has been a double-digit increase in food and beverage revenue and the highest customer satisfaction score in all participating airports. OTG Management is the hospitality company behind Delta's terminals. They've turned to TechServe to provide, configure, and install the world's largest deployment of iPads. It's a number that just keeps growing as they add new terminals. And TechServe really was the natural place to turn. You see, they sell, support, personalize, configure, and manage massive iPad projects, from the Delta terminals to a school with 700 chef instructors to an operation that delivered personally configured iPads to 3,000 cable technicians. TechServe is also able to do full lifecycle management for all of your technology needs by providing the devices that you need, getting them up and running, teaching you and your staff how to effectively use them, and managing them so that they're working efficiently. TechServe also provides ongoing support so that if your enterprise has a problem, help is never further than a phone call away. Now, if you're considering adding iPads to your business, why not ensure your project's success with the world's most experienced partner? Here's what we want you to do. If your business is considering integrating iOS technology at your workplace, then contact TechServe today and receive a complimentary iPad deployment assessment. Visit techserve.com/Twyett, and TechServe will help you assess your current or future iPad needs and give you advice to make it a success. That's techserve.com/Twyett, techserve.com/Twyett. And we thank TechServe for their support of This Week in Enterprise Tech. Now, let's get back to it. We've got a couple of big stories here. The first one is, well, I'm calling it 1,000 cuts, the end of net neutrality. Now, here's how the story works. A while back, we talked about peering arrangements. Peering arrangements are what telcos do with one another. For example, Cogent, which is one of the largest bandwidth providers in the world, and Verizon, which is one of the largest last-mile operators. So they can actually connect that bandwidth, that backbone, to your home, to your office. Now, they're getting into a bit of a tussle here because it turns out that Verizon is killing Netflix. That's right. If you're a Verizon customer, Netflix is being delivered by Cogent, delivered over the last mile through Verizon, but Verizon is not living up to their end of the bargain in the peering agreement. Now, here's how it typically works. There are handoff points. There are exchange points between the two networks where the traffic must flow. Because they're peered, they've agreed to allow each other's traffics to flow freely through their networks and basically not charge each other anything. But in order for that to happen, they have to maintain the links. What Verizon has done is they've changed how they handle the interchange. Whereas most interchanges are upgraded once they hit 50% of capacity, Verizon is letting them go all the way to 100 and even oversubscription before they start even thinking about upgrading the interconnection points. Now, Chibert, tell me, what would be the direct effects of me having a peering arrangement, say, with you, and then deciding that I'm not going to upgrade the equipment that runs between the two networks?
Lots of stuttering, lots of dropouts. It's nasty, And the whole trick with video or of any sort is it needs consistent packet delivery, and if you start having dropouts, your video goes to crap because one frame is dependent upon many others. So this whole thing of people saying, well, we can get away with cheating a little bit, and instead of upgrading that link at 50%, 60%, we're just going to keep going till it's like 80, 90%, which really stinks because networks don't like running at 100%. They actually don't even really like running at 90% because network traffic in general is bursty. So a lot of this is just vote with your dollars. You need to complain. I'm on Oceanic, which is a Time Warner cable modem. And I am very well known to the operators because every time the performance of my cable modem starts to stink, I call and I complain. If you don't call and you don't complain, you get whatever you deserve. You need to call. The squeaky wheel, in this case, really does make a difference because in the case of Oceanic, if I complain and enough people in my neighborhood complain, they consider splitting the collision domain so that I'm competing for bandwidth with less people. And Oceanic has actually gone and upgraded their WAN connections in a couple of cases because enough people were complaining that things like Netflix just didn't work. So call, complain, shut down the Verizon call centers because of overloaded call traffic. Give them crap because you as a consumer need to vote with your dollars.
Right. This story is about Netflix specifically because Netflix is one of Cogent's, if not their largest, one of their largest customers. And so they provide a lot of traffic, a lot of bandwidth to Netflix, to the streaming movies that are going to go over the last mile of AT&T and Verizon and whoever else has that last mile of copper. But this story also affects those who are running enterprises because it's really talking about the peering arrangements. I don't think a lot of people understand how fragile the peering arrangements actually are. And without peering arrangements, as we spoke of on Twiat a few episodes back, we don't have the internet. If networks just suddenly decided that they're not going to do anything actively to help the traffic of their peering partners, as you said, we get a lot of stutter, we get a lot of latency. We would basically just shut down the internet, right? Well, Cheever, tell me, what's the worst case scenario here? If the peering arrangements become void, or at the best, if they become neglected, what happens to this wonderful thing that we call the internet?
It turns into a slug, basically. You know, if the good news is that if Verizon keeps being stupid about peering arrangements, people are going to stop using Verizon. But further up in the stack, say if someone like Quest or BBN Client or Signet or someone like that starts mucking around with their peering, peering agreements, they're going to start getting bypassed because the internet is not just a set of set routes. It is a very amorphous thing. You can reroute a lot along many different routes. It's just that this is causing a lot of problem because Verizon is the last mile. So unless you're changing providers to your home or to your office, you don't have a lot of choices. Some corporations have actually gone as far as, say, putting in, say, WiMAX or just having dual providers just to get around problems like this. And it's getting cheaper and cheaper to do it. More and more modern firewalls have the capability of doing load balancing. So that might be something you might want to consider.
Right. It is worth noting that this has happened in the past. We've had these disagreements. If you do a quick search, you're going to find out that you've had Cogent versus Level 3. You've had Cogent versus Cox. You've had Cogent versus various telcos in different countries from BBN Planet and Telesonora. So these disagreements have happened in the past, and typically what will happen is traffic slows down until, as Chibert mentioned, people start calling and they start demanding better service. And at that point, when they see dollar signs at risk, they actually do fix the interconnection. So as you said, yeah, the squeaky wheel gets the grease. Now, Chibert, you know what else gets the grease on the internet? That's a setup.
You know, I don't know. Tell me, Padre, what else gets the grease?
Routers. That's right, routers. We have another story here from CNN.com that Cisco is supersizing their core routers. Now, remember, we're not talking about the router that goes in your home closet. We're not even talking about the router that's going to go into your office. We're talking about core routers, the big boxes, the big machines that support the backhauls running across the country in between telcos. Cisco is updating their CRS line of routers from the CRS3 to the CRSX. Now, imagine this. Every slot in this chassis can provide up to 400 gigabits per second of throughput. Every chassis can be scaled up to 6.4 terabits per second, and multiple racks of the CRSX can be chained together to provide up to 1 petabit per second. Now, this is compared to Cisco's previous generations of routers, the CRS3, which topped out at 322 terabits per second, and the CRS1, which topped out at just over 100 terabits per second. So we're talking about an order of magnitude. This is crazy faster than the premier router that was released just 2.5–3 years ago. Now, Cheeber, let me ask you, what would you do with all of that speed? Because one of the comments that I see a lot is, well, why do we need that? Because, I mean, heck, I'm not even scraping the edge of my gigabit link yet.
You know, funny you should ask. Just this last week, I was actually in the Makaha Cable Landing Station that's run by AT&T, and they just got finished with a huge upgrade And they are actually dropping in some of the new Siennas and some of the new Cisco routers. And the reason why they're doing it is the floor space in cable landing stations, the floor space in editing, transit stations across the United States or across the world are some of the most expensive real estate on Earth. So you want to have you want to condense your equipment. You want it to be able to handle more bandwidth. The cost of these fiber optics, you want to be able to go and maximize their use. So it's actually gotten to the point where a lot of the intercontinental cables are now set up with analog repeaters so that they can start playing with things like wave division multiplexing, dense wave division multiplexing, and things like that. All that takes more and more hardware. Those boxes that you showed in that screenshot, those things are massive. They actually have giant eye bolts in the top because they're designed to be moved around by cranes. And they're not 19 inches wide, they're 21 inches wide. Those are designed for telco racks, not standard equipment racks. Right. We actually had one that we used for an interop for the multicast because we needed something that was really fast. And in those days, we weren't able to do certain types of multicast routing unless you were in the biggest platform. That thing came in coffin-sized crates, actually bigger than coffins. And they made a sound, something akin to a jet plane when you start it up. But those are the actual heart, the brains of the internet. Without routers that big, the internet would never have been able to scale anywhere near where it is now. So I give Cisco kudos for upgrading what was actually getting to be a pretty old platform. And thank you very much. And gee, maybe you might actually be able to give Sienna some real good competition now.
We're geeking out because we love gear like this. We love it when we get it in for interop. We love it when we actually get to run bits over it. But I think there might even be a better explanation that the regular person, that the geek, that the lay person might be able to understand why these faster and faster core routers are important. And for that, I bring in a super, super special guest, Miss Molly Wood.
On to our emails, which are slightly more on topic, at least the ones we picked. Father Robert writes in and says in episode 1181, Brian Cooley poo-poos the introduction of the Cisco CRS-3, saying they all do this, assuming the entire internet is populated with these. I mean, they forget this is the fastest thing on the internet, and the internet runs as slow as the slowest gateway on the internet. So until this hardware propagates everywhere, this will be sitting around drumming its fingers like a bunch of older hardware. Now, we kind of let that lie. If Rafe had been here, clearly he would have lost his mind.
I would have.
But Father Robert also lost his mind on our behalf. He said, while the weakest link analogy is most often the case when speaking of advancements in IT, where the technology will only work as fast as its slowest component, it isn't true in a case of this scale. It helps to think of an ISP as an outwardly concentric network comprised of the core, the center, and edge, the part of the network that actually connects to customers. The edge networks have been fast enough for years, with most users' bandwidth needs not scraping the sides of even a 10 megabit connection up to the ISP. However, as you get closer to the core, all those millions of 10 megabit connections quickly overwhelm or oversubscribe the core router. Okay, here goes Nerd Voice. With the Cisco announcement of the CRS-3, an ISP could now serve 3,220,000 customers with a 100 megabit link without oversubscribing and without deploying them everywhere. Plus, put a few of these in key places in the core, and bit bam boom, you got yourself a next-gen network capable of downloading every episode of BOL directly into the brains of our future army of Cylon babies. More to the point, as long as there are at least 2 of these deployed in an enterprise or ISP class network, they will never be drumming their fingers.
Now, that was back in 2010 when Cisco released the CRS-3, when people were already saying, wow, this is stupid. Who's going to use this? This is way too much bandwidth, even for the core. We don't need this. And since then, we've realized that, yeah, the core bandwidth is starting to get oversubscribed. And so we need something like a quantum jump. Whereas the CRS-3 did 3 times more than the previous generation, the CRS-X is going to do something like, what, 5-6 times more than the previous generation? Chibert, this is going to have to continue, right? As bandwidth gets more of a consumable, as our applications, as our services are demanding more and more speed, we're going to have to keep coming up with better ways to fit bits across the same pipes, yes?
Lieutenant Uhura, please open subspace communications to Deep Space Nine.
Yeah, that's what we're looking at. Yeah, we need a way to force more bits right through our pipes. Now, we're going to move on a little bit because we've been talking a lot about the backbone. We've been talking a lot about peering. I do want to bring up one story that was actually a breaking story. It came up just before the start of This Week in Enterprise Tech, and that's a story from ZDNet about how Microsoft is going to be killing off their TechNet subscriptions. Now, to the average user, that might not mean anything, but Chibert, tell me, what is TechNet and why is it important to enterprise professionals?
Please don't kill it off. I live and die by it. I could never, ever, ever afford to run this lab if I didn't have TechNet. You know, just having the ability to download trials, to be able to get early access to bits, all kinds of stuff. I would never, ever be able to afford to license up everything with standard licenses. Basically, what TechNet is for developers. Its actually full name is actually Microsoft TechNet. It's also Microsoft Developers Network. It is so that developers and high-end techies can prototype things in a lab environment, try it out before they go and make a commitment. My personal opinion is if TechNet or Microsoft Developers Network ever gets killed, Microsoft's market, especially in the small to medium-sized corporation, is going to collapse. It will be one of those things that's going to push people back towards Linux because then they can afford to prototype. Right now, I can afford to prototype things. I'm actually setting up a HP C7000 Blade server, and that's going to be prototyped using Hypervisor, the new server 2012 R2, because I'm going to be bringing up a private cloud. If I didn't have access to it, one, I would never be able to get access to server 2012 R2 early because it's not shipping yet. It's only in preview. And secondly, I'm going to need something along the lines of 48 CPUs worth of license, and that's going to cost an insane amount of money. So I might as well close my doors.
Right. See, that's what puzzles me about this. The details of the closing will be that it's going to shut down August 31st. If you have your subscription before then, it will shut down when your subscription ends. Now, they are keeping the MSDN subscriptions, which have risen from $199 and $299 annual cost to $699 and $499 annual cost. So they're really jumping up the cost of their software. Chibert, any insight as to why they're making this move? It would seem to me that, especially with Windows 8 not being the grand success that they were hoping it would be, that raising prices and alienating developers would probably not be a good thing to do. Is this another case of one side of Microsoft not talking to the other?
I'm sure hoping so, because it's, let me tell you this, the price of the MSDN Ultimate is up to $7,000. It's not cheap, but it still is cheaper than the alternatives. And if Microsoft doesn't go and pull the cotton out of their ears and have one side talk to another, they are going to have a really big surprise, because this is something that is near and dear to a lot of corporations' hearts, and is one of the reasons why there's been so much loyalty to the Microsoft platform for certain types of developers. So right. Microsoft, buy a clue.
Buy a clue. As I think it's best summed up by Cabo Zone in the chat room, who says, the part of TechNet is now known as BitTorrent. Sad but true. Now, we here at Twiat and This Week in Tech Network do not support piracy, but we understand when the writing is on the wall. Now, coming right up, we're going to be talking about the future of Wi-Fi. But before that, I want to take some time to talk about our second sponsor, and that's all about MailRoute. Now, do you need a migration plan away from Postini or Forefront? Then please, you owe it to yourself. You owe it to your IT administrator. You owe it to the hours of backbreaking work that you'll be spending alone in a server closet if you don't check out MailRoute. Now, MailRoute is a hosted email filtering service in the cloud for businesses of any size. There's no easier way to filter your email. You don't need hardware or software. You just point your email to MailRoute, they filter it, and they deliver the clean email stream to your mail server. MailRoute reduces your cost by eliminating 90% or more of your server load. They decrease the amount of bandwidth that you need, and more. There are no upgrades or updates that you need. MailRoute never becomes obsolete because it's in the cloud, because they manage it. Because MailRoute is in the cloud, it eliminates the need for having a dedicated server for your spam filtering. All that's necessary is to sign up with MailRoute and then make a single change to your DNS MX records to start the flow of clean email. You don't even have to own or manage your email server. As long as you have your own domain, MailRoute can filter your email and send it off to your server wherever it may be. MailRoute's dashboard gives you direct control over every aspect of your service, from setting the sensitivity of the spam filters to adding domains or users and managing whitelists and blacklists. End users can manage their own settings, and administrators can control them all. It's like the One Ring. MailRoute offers free customer support to accounts of all sizes, single users on up. Now, here are a few interesting facts. Over the last 12 months, we've blocked over 235,000 spam messages for Tom Merritt. That was 99.7% of his total mail volume. We've also blocked nearly 600,000 messages for Leo in just the past 12 months. That's over 12 million messages blocked by MailRoute for Leo since he started using the service. MailRoute has store and forward included with the standard service that holds your mail up to 15 days with no file limit if your server goes down, which means that MailRoute essentially becomes your disaster preparedness backup server. Now, here's what we would like you to do. We want you to try MailRoute for free. MailRoute will price match on Postini or Forefront contracts. You can visit mailroute.net/signup.html and enter the promo code Enterprise7 to start your 15-day free trial. That's mailroute.net/signup.html, promo code Enterprise7. There's no credit card required for the free trial, and we thank MailRoute for their support of This Week in Enterprise Tech. Now let's get back to it. We've got a super special guest, Mr. Bruce Miller from Xeris. Bruce, thank you very much for coming on to the program. Why don't you tell the group playing at home who you are, who you represent, and, well, what you're doing here.
All right, sure. So I run the product marketing group here for Xeris. We manufacture wireless products for the enterprise and have been doing so for about 7 or 8 years. I've been here myself about 6 years. And the Wi-Fi landscape has changed quite a bit recently. You talked about some of the future of Wi-Fi type of technologies, and we have some pretty cool things that are coming down the road here, some things that we've been doing for the last a year and a half or so with some of our new product lines. And we'll talk a little bit more about those today, as well as just how the technology is developing. In general, we're all about supporting high-performance Wi-Fi. You mentioned, or we were talking a little bit earlier about the bits at the edge of the network. Tends to be enough bandwidth to support a lot of the applications or the things that the users are running, but things get congested as you aggregate that. Certainly from a service provider perspective, that's the case. Wi-Fi, wireless in general, has kind of been somewhat the opposite at the edge compared to wired technologies, and we're all about making and enhancing and enabling that technology at the edge of the network to truly give high performance and the ability to run wireless for any application, no matter what it is.
Now let's get to something that the people in the chat room are picking up, and that is you are the maker of the, as they call it, the UFO router, the UFO Wi-Fi array. I brought it onto the show several times. We showed it off on our flagship podcast, Twit. It's a very cool piece of technology because it's an efficient use of Wi-Fi spectrum. If Jason will play the Xeris One B-roll, we can see how one of these things is put together. This is your new array that we're seeing here on screen, but the idea is the same as the old one, and that is rather than shooting out energy into multiple directions, omnidirectional, just getting it out there, you are looking down a particular azimuth. You're dividing the 360 degrees into different slices so that you can reuse channels, you can reuse frequencies in close proximity with one another. We've seen it in the real world, and it is a far more efficient use of the Wi-Fi spectrum than any other solution out there. Tell me a little bit about this solution. How did Xeris come up with this way of doing Wi-Fi?
Right. So it kind of goes back to our founder about 8 years ago was looking at some of the technology options with respect to wireless. And there was a lot of money, a lot of focus going into the devices, and a lot of the things that are actually creating the mobile device proliferation that we have today. Nobody was really addressing the infrastructure side of things, and the technologies that existed back then and still propagate today are really overlay technologies. They're really wireless that's designed as a hotspot, as kind of a nice-to-have type of thing, overlaid on top of the network where you also have wired interfaces. Well, anymore, you don't have that option. You know, smartphones, tablets, you know, MacBook Airs, most Ultrabooks, there's no longer an Ethernet connection. And so the technology needed to be put in place to support that proliferation. The motivation came from the cellular industry, mobile cell towers supporting multiple radios on each one, directional antennas, creating cells of coverage, and being able to scale. You know, 15 years ago, you didn't have a lot of mobile users. Now there's, you know, everyone has a device in their pocket, and some have more than one. And so you know, I'm talking about a mobile phone. And so that industry had to really come up with a better way of doing things. The same technology is what we've really applied to the array here, and you're showing the modular array there. You can populate multiple radios into the same device. I can add more. I can create larger chassis. I can add more spectrum support per array to support that scalability. And that motivation, you know, from, say, the cell industry and some of the lessons learned is what we've really applied to Wi-Fi. And then we essentially create a mobile cell tower for Wi-Fi indoors with this array, and it can scale up to, you know, thousands of users.
Right. So we've got the efficient use of the Wi-Fi spectrum, but we add a layer on top of that, and that is the newest, the latest, the greatest, the future, at least for now, of Wi-Fi 802.11ac. There's been a lot of noise about 802.11ac, but there's also been a little bit of reservation because people did not want this to turn out to be another draft and fiasco where we had a protocol, a standard that was released, kind of, and then had to be modified, changed before it reached its finalization. We do have a final standard of 802.11ac. Tell me a little bit about it. Why are people in the Wi-Fi, the wireless business, so excited about AC?
Well, it takes wireless to the next generation, to the next level. And I think you mentioned the whole draft issue with respect to 11N. We went from a 54 meg technology to 450 meg, you know, within a couple of years, and it was a pretty significant transition. And things got a lot faster, but there was a lot of, you know, cutting your teeth on the new technology and how does it really work and what are the implications of it. MIMO, which is multiple input, multiple output, is so much different than SISO, single input, single output Wi-Fi, and that's how we gained a lot of that speed improvement. So I think the lessons learned in that transition was a little bit challenging, and the industry took a lot longer to certify that standard than what they may have expected. Lessons learned from 11N really translated to 11AC. I would term the initial release of 11AC a more incremental change to 11N by far than 11N was to 11ABG. There's some new things coming out with 11AC in a couple of years that are even more exciting. But in the immediate time frame, we're really talking about tripling the speed of 11N to 11AC. It's faster. It's going to be lower cost per megabit by far. There's some exciting things in there in terms of reducing the power requirements on the end devices. So it's just taking that next generational step. I can get more bang for the buck, more power out of my connection, especially for things like smartphones that are very limited. They can't get the full range of 11N capacity, but the technology under the hood gives them greater capacity just by moving up to 11AC. Even if they don't add more antennas and all those kinds of things, they'll still benefit from it. So everybody stands to benefit. I think the industry is going to move a lot quicker to 11AC than they did 11N, just based on the fact that the costs are going to be there, more advantageous. There's going to be, you know, power consumption improvements, and the infrastructure, you know, to support that is going to be more easily and readily rolled out than it was, a number of years ago with 11N. So a number of differences, but some definite improvements in the wireless performance that we can expect to see here in the short term. So I think it's a very exciting time actually for wireless. It's everywhere. It's permeating many different kinds of devices, not just laptops anymore. It's everywhere, and you have to back that up with the infrastructure to support it.
Right. Cheebert, I'm going to throw to you in a bit because you've actually had experience deploying a lot of Xeris arrays in enterprise campus environments. But 802.11ac includes a couple of brand new features, including extended channel binding. It supports up to 8 spatial streams versus 4 which was the support in 802.11n. It supports multiple STAs, which are devices that can support the 802.11 protocol, each with their own set of antennas. So you can have multiple radios, multiple devices making connections at the same time. It supports multi-user, multiple in, multiple out. It's a form of space division that allows for multiple devices to be served simultaneously, which is actually a big change in the way that Wi-Fi is normally served, which does time division. One slice of time for this device, one slice of time for that device. It also supports beamforming natively. It's not an add-on, it's actually in the standard. And it can technically provide between 433 megabits per second and 6.77 gigabits per second of throughput. But my question to you is, these specs are in the lab. How much of this advantage will we see when we deploy these arrays in the real world?
Actually, one of the things that I want to point out is more antennas, more frequencies, more RF in the air means greater need for coordination. Keep in mind, a lot of offices have a heck of a lot of metal, and actually because they love plants, there's a lot of water. Metal reflects, water absorbs. So what you start ending up with is you start getting beams of energy blasting all over the place, and you start getting lots of reflections. So as the trend goes to smaller and smaller antennas in your devices, keep in mind some of the antennas on things like, say, a cell phone is smaller than a dime in diameter for some of the different frequencies, smaller than a quarter in other cases. That's not a whole lot of surface area to radiate energy. So being able to manage the energy better, only sending it where it's needed, taking a lot of clues from things like the Big Eye radar from the Aegis cruisers, you start being able to steer, use beamforming to only send energy where it's really needed instead of going to the spray and pray that a lot of other access points with the rubber ducky antennas try to use. It's a much more intelligent way of using energy, and it's, as a result, you get a lot more reliable connections. Reliable enough that we did a demonstration at Interop a couple years back where we literally had 1,000 iPads running simultaneously, all running video during a keynote at Interop.
Right. Bruce, let me go back over to you, because this is one of those things that I think IT professionals and even the geek layperson has become a little bit jaded by, that they hear all the specs and then they don't actually see the performance when it makes it into the consumer product, when it makes it into their phone, when it makes it into their laptop. We are finally seeing AC devices make it out in the wild. The newest MacBooks seem to come to mind. Some of the new devices that I'm seeing in the Ultrabook format are also including AC. How much do you think of this performance will we see transfer into real-world performance?
Right. So I think one way of looking at that is maybe to term it in terms of a relative improvement. So the maximum rates that you can get out of 11AC in the Wave 1 products that are coming out this year is 1.3 gig. More or less, that's the number that people are targeting. And then Wave 2 and future versions are going to get to 3.5 gig and upwards towards 7, as you mentioned earlier. So I think if you sit down with a device, say a phone, and you're getting maybe 20 meg out of that thing, at a couple rooms away from the AP, and then you would or next door, what have you, and then you replace that AP with 11AC, you could very likely get two to three times that rate, just depending on, again, the signal level, where you are, et cetera. But the technology itself raises that bar approximately that level. That's going to vary. You might get right next to the AP in the same room, strong signal, and have a very nice response. The further away you get, maybe that delta, that improvement's going to tail off a little bit. There are so many variables within wireless, but the bottom line, though, is the modulation. The actual bottom line bit rates are improved. The ability to bond channels to 80 meg is there that wasn't there before. So there's some fundamental things that are part of the standard. Is every device going to be able to take advantage of that in all the different ways? No. A laptop will. A smartphone will benefit from some of those elements, but to Chiver's point, the antennas, the limitations on the devices themselves are always going to be a key factor. And so your mileage will vary, but I think that from the beginning, look at setting up the network in a way that that is best optimized for that. And there's a lot of techniques that are coming into play that most people ignored in the past. They just kind of blindly deploy the wireless. But now there's specific best practices for the different bands, 2.4 versus 5 gig. Looking at your noise floor, moving into more 5 gig support. These are the things that come into play for the design of the network that are ultimately dictate how well and how much benefit you get from the new standard.
Okay. Bruce, let me ask you, as a product manager, as someone who's seen these products develop over the years, going from 802.11a, b, g, and AC, what is it that excites you the most about 802.11ac in the enterprise? What are the things that we'll be able to do that we haven't been able to do in the past? What are the new services and the applications that you think the next generation of Wi-Fi will enable?
So, yeah, good question. I mean, I think that, the raw speed is kind of the obvious one that everybody will benefit from. But more importantly is the fact that we're in a day today where we have so many different devices supporting Wi-Fi. In 11N days, more or less, when it first came out, laptops were probably the primary user of the technology. Now that we're, say 5 years later, with so many smartphones and tablets and just, projectors, printers, all types of devices being thrown on the network, the ability of 11AC to more broadly encompass the performance benefits for all these devices, and then inject things like, power savings, to these mobile devices that are, obviously trying to gain more battery power. You're packing things in smaller and smaller, and if we can make that faster at the same time, that's a benefit for everyone. The technology itself has not shown from the chipset manufacturers to be a huge incremental cost as well. So we'll be able to take advantage of that greater performance without as significant a boost in the cost per megabit as we had seen in 11N days. And then moving forward, multi-user MIMO, which you talked about previously, this is really taking Wi-Fi more from being more like a hub technology of Ethernet that you had 20 years ago, and moving it into the world of switching that we have today, where you have dedicated pipes and you can get multiple users communicating at the same time. You couldn't do that in the past with an access point with on one radio. Everybody's got to share and back off. Multi-user MIMO, allows users now to communicate at the same time, and that's now coming in a couple years as well. So that'll be another performance boost. So I think there's a lot of different elements to consider, but it's exciting based on the fact that we have so much wireless being deployed today that now you can even do that better, and that there are so many different manufacturers and technologies being taken advantage of that we didn't in the past. I mean, it's phenomenal to look back, where we were just 15 years ago, and you're talking several megabits to now being able to talk about gigabits. I mean, you're talking, multiple orders of magnitude. So that technology curve, continues to ride. It's not like we're sitting here at the end. The FCC and others are looking at opening up new frequencies, new bands that we're going to be able to communicate in. So we're excited about the prospect of making wireless much more robust and usable, where in the past, again, it was that kind of overlay or, kind of nice to have technology.
Bruce, I love the fact that you also brought up the multi-user MIMO. Chibert, let me ask you about this. A lot of people don't realize that Wi-Fi, as most of us are using it right now, is using that share and back off technology. If I have an access point connected to 10 different devices, it's not actually contacting, it's not communicating with all 10 devices at the same time. There's a time division there where it goes from one device to the next, to the next, to the next, to the next, to the next. And it has to do that because of the limitations of the technology, the limitations of how it's using the spectrum. With AC, with multi-user MIMO, it can actually maintain connections with multiple devices at the same time. Now, again, there's a big geek side to that. I love that technology. But what services would be enabled? What services would be made better by the fact that you can maintain a consistent connection with multiple devices per radio?
Actually, the first service that really comes to mind actually is E911, Enhanced 911. Hospitals use this a lot. There's actually a device. It's a little pendant. Think of it as a Star Trek communicator badge Mark I. I actually sent one to Michael Okuda at Paramount. And you actually have voice recognition. You can actually punch the button and say, find me the nearest respiratory therapist. And it'll use the direction finding, in order to locate the nearest respiratory therapist and create a voice channel to that person so you can get them to the emergency situation in a big fat hurry. It didn't work that well because a lot of the Wi-Fi technology didn't support it. Now with things like what we're getting with MIMO and AC and so forth, now all of a sudden we're starting to finally get the constant connection so that the accuracy of where a person is within a building is much higher. Not only that, it also gives us the ability to create things like voice connections significantly faster. The whole idea of being able to roam. You know, when I did some of my initial Wi-Fi testing, laptops tend to be very, very sticky. They try to hold on to that connection, even though you might not have an optimal connection anymore. So if you're wandering around a building, being able to rapidly switch and roam from access point to access point is a pretty big deal, especially when people start using voice over IP Wi-Fi handsets. So lots and lots of good things happen. My only point that I need to make is RF is a limited, it is a single pipe. Even though you're using multiple connections over it, it's a single pipe. So I'm sorry, Bruce, but nothing is ever really going to be as fast or as reliable as a wired connection. But darn, Wi-Fi is getting pretty good anyway.
Pretty damn close. I like it.
Yeah.
Bruce, I want to throw back to you because we've got CR1 in the chat room and actually quite a few others who have seen the Xeris solutions. They know that I'm a Xeris evangelist. They know that I really like the tech. I've played with a lot of different wireless technologies. There are some really good wireless technologies out there, but I tend to always go back to Xeris. But the question is about the sticker shock, especially for the small business, because let's be honest, Xeris arrays are objectively expensive. Relatively, they're inexpensive, but objectively, if I'm running a small business, I would never be able to afford a Xeris product until this last May when you released a brand new AP. I do want to give you a little bit of time to talk about the 520. We ran a video on Twiit about 2 months ago, but tell me, what is the 520?
Right. So, yeah, you're right. The perception sometimes that Xeris has this expensive kind of platform, and actually it's based on the fact to a certain extent that we put so many radios into one device, and so when you look at the total price, it's more. But if you actually break it down, it's really the equivalent of all these APs and all these controllers. So the total price is less. But the 520, which you kind of have open here, is actually a regular AP from an RF perspective. So we don't have modularity built into this product. We have two radios that are fixed, and then all of the other controllers and all of the other elements, the Array OS operating system that we run, is all integrated within this AP, just like we do with our regular arrays. And so the 520 is controllerless. It's an AP that does not have any central component that is required to operate it. So similar to what you might expect or see from some other vendors with respect to just standard APs, the 520 supports that controller's kind of model. It supports all of the other capabilities of the arrays in terms of application level control. We actually do DPI directly at the edge of the network in the AP itself and in all of our arrays. So we have a common type of deployment strategy across the entire board. And the access point is significantly less from a cost perspective than you might see from the arrays on a per radio basis, but they all work together. So I think the bottom line here for the viewers is that Xeris has a full range of solutions, all the way from a very, very cost-effective AP, zero-touch, cloud-based provisioning, all those good things, all the way up to super high-density arrays at the top end that can support thousands of users and everything in between. And actually what we see from most of our customers is they deploy a mix of them. They might have some 520s in some areas that are low to medium coverage. They might have some higher density arrays in the places where they need them at the same time. But I think the key point here is that one size does not fit all. And if you're talking about Wi-Fi that's just generally deployed in an overlay fashion and you didn't have a lot of users on the network, then an AP is fine. But in today's world with smartphones and high density, you have to have the ability to scale, and the standard AP just will not scale past a certain point. It just starts to fall down in terms of just scalability. So that's where the arrays come in, and we now have the ability to support all of those use cases. And that one, again, the one-size-fits-all paradigm really doesn't work today the way it may have 5 years ago.
Yeah, I like it. And for UCR1 in the chat room, just because I love you, there you go. So if a Xeris array is going to run you in the thousands, but a 520, which is Xeris's AP, is going to run you in the hundreds. A very, very good option for the small business that wants a bit more professional, let's just say, connectivity than something you might buy at Best Buy or Fry's Electronics. Now, Bruce, I do want to ask you one last question, and that is, what do you think the enterprise should be doing right now to prepare itself for AC? Because we're starting to realize that this is not just another protocol. It's not just, oh, a little bit of extra speed or maybe a little bit of extra connectivity. AC is actually very different. It is as far different from the draft, from the N standard as the old proprietary radio, wireless radio, was from the 802.11a and B. So what do they need to know as they go forward with their wireless deployments?
Right. So I think that anybody buying into wireless today has to consider 11AC because it's already here on your network. Whether you know it or not, Galaxy, you know, their S4 from Samsung smartphone, the MacBook Airs, they already have 11AC. So if you support a BYOD strategy, it's already showing up in your network. So you have to be looking at 11AC and where you're going with that technology if you're purchasing today. The consideration is challenging, though. If you look back over just the last 7 years or so, we've introduced 4 new technologies, or will be introducing 4 new technologies: 300 meg 11N, 450 meg 11N, Wave 1 11AC, and within a couple of years, Wave 2 11AC. So looking at swapping out or updating technology every 2 to 3 years is pretty daunting. So our approach to that is let's get ahead of the curve and come out with a platform that ultimately supports the ability to migrate from one to the next. And our 11AC module, actually, of which we actually see right here, similar to what we actually were showing earlier on the video, actually supports a Yagi-style antenna here and has the ability through a modular interface to snap into our existing arrays that we have sold. And so those arrays that you already talked about that have been sold since 2012, even the end of 2011, already support 11AC. As soon as that module comes out, you can snap it in. So I think the consideration to make is, if you're buying today, what is the migration strategy to 11AC by the end of the year or by the next year from your vendor? Are you going to have to swap out that AP, or can I just snap in a new module using that modular-based approach? And then in 2 years from now, what am I going to do when Wave 2 comes out and I have multi-user MIMO, which a lot of people are interested in or maybe even holding out for? So migration, very important. From a design perspective, 11AC has faster rates, greater receive sensitivity. It should be able to snap into the same locations to a large extent as 11N APs. However, you may have to look at updating the backhaul power, or the backhaul, if you're running 10100 out to those APs, you're probably going to need gig if you haven't already updated. Power consumption considerations have to be looked at as well. But it's really going to be driven a lot by the clients. You're going to see 11N in your network a lot faster than, 11AC coming into your network a lot faster than 11N came into the network 4 or 5 years ago, because with BYOD, these devices are just everywhere. So you have to start that planning consideration and not lock yourself into something that's going to be difficult or expensive, more to the point, expensive to upgrade at a future point in time. There's a lot of things below that at the next level down, in Geek Talk to get into in terms of how the technology is going to differ. But I think, first of all, map out your requirements, understand your clients, understand where you're going to the extent that you can, and then take those considerations into any kind of purchase that would take you moving down the road. And by all means, make sure your vendor has a strategy to get you there and isn't locking you into a hardware solution that's not going to be able to migrate.
Cheever, last words from you. Same question, which is basically, as an engineer, as someone who's actually been deploying these arrays, deploying these APs, what would be your advice? As we move towards AC, we see a technology that will have greater range, greater sensitivity, greater throughput, and a lot more features and options that weren't possible with the previous standards. What would your advice be to the IT professional out there who is looking to upgrade? Should he move on AC? Should he be waiting for AD? Should they be looking at a technology solution for BYOD?
Actually, I think one of the pieces of advice I'd like to give anyone considering Wi-Fi upgrades, Wi-Fi changes, and so forth is don't just look at the purchase price. We actually were doing a Wi-Fi survey for a lab for the nursing school, and I was going to be able to do 116 radio array, one Xeris inside, and then one smaller one outside. I think I was going to be able to use a 4 radio array to handle the entire simulation laboratory. The same thing with another brand was going to be close to 15 access points. And in addition, it had a annual recurring cost for licenses. So not only do you need to look at the initial purchase price, you need to look at what the entire system is going to cost you and what is this system going to cost you over a multi-year lifespan, because that's where some of these guys are getting caught on bidding wars. They just drop the heck out of the purchase price, but they catch you on the recurring costs. So that's my advice. Look at what it's going to cost you in the long run and start planning. You need to look at when can you afford those upgrades and then program them into your budget long term.
Well, gentlemen, that's it. We've done it again. We've let our audience use the last hour and 14 minutes listening to the best dang enterprise tech podcast in the world. That's right. I took a poll just now, and we won. But I do want to thank my panel for being on for well, just some absolutely fascinating topics, especially to Hans. I'm not going to try to say your last name again because I did well the first 2 times, and I'm not going to kill it. The CEO of Rincredible. To Brian Chi, over to you. How is the Geek in Paradise doing, and what should we know about your upcoming work?
Well, hopefully I'm going to be changing the @ in my bottom third really soon to @ThinLinks. And that's how we're going to be announcing when we're finally shipping the review units. We've got kind of a little going back and forth on in what form we're going to release everything. It is a very nice day, and I'm hoping to empty the black hole loft in my lab out onto the roof so we can sort things and fill up dumpsters and make this lab usable again. Padre,
we should have a contest. We should have a contest for the Twilight Riot to win a box of crud from Cheebert's Black Hole.
Well, you know, if you're willing to buy the licenses for some of these things, it would be pretty good, because I'm actually going to be throwing away some insanely expensive test equipment because I can't get licenses anymore.
That's it. So Twilight Riot, everyone tweet over to Cheebert and see what you can grab. Trust me, I've been up into that loft space, and there is some amazing technology that's been sitting and gathering dust. Over to you, Bruce. Bruce, thank you so very much for coming on. It was a pleasure to talk to you at Interop, and you know, you are a wealth of knowledge about all things wireless. Tell me what's going on at Xeris. What should we be watching for, and what do you want our audience to know about?
Yeah, thanks, Padre, for having me on here. I think that coming from Xeris, you know, we touched base about 11AC, which is certainly the top of mind for everybody right now. So stay tuned for more things happening on that front, some more exciting things with respect to the development of that technology and how to get you, the customer, you know, your wireless network upgraded and something that's going to last and take you out 5+ years. You know, Xeris has been very active recently in a number of different announcements. You're showing some on the website there, a series of new switches that we have come out. Cloud-based applications, I think you'll see a lot from us in that area. The number of different cloud services that enable the small to medium enterprise to make wireless easier and more readily available everywhere. You know, we have to look about scale and being able to push out wireless into remote offices and locations all over, and doing that very simply and fast. And so we've been putting a lot into improving and furthering our solution to be able to put the Xeris technology in many places where it hadn't been before. And that means expanding the product line and improving things there. And then moving forward into the next few years, you know, Wi-Fi is not stopping. There's new things coming down the pike in terms of technology that's going to enable and make it even easier to run. So 11AC is maybe the more obvious one from just the raw bits and the speed of the technology. But Passpoint, where you have automatic registration and very easy to get on Wi-Fi networks without having to go through the connections on your device to connect. You know, I see that as being a game changer, and certainly for hotspots and a lot of the carriers to be able to enable technology there. You know, we're already Passpoint certified, for example, and that's an area that we support. So some very exciting things going on. If there's any indication, the Wi-Fi Alliance meeting, which just happened recently in Seattle, was was just a buzz with so many different things happening, and it's an indication that there's a lot going on in this space, a lot of exciting technologies coming out, and we certainly consider ourselves on the forefront of making sure that those get out to our enterprise customers, and we'll propagate those through our platform.
Thanks again to our panelists. It's been a fantastic episode. It's been a lot of fun, and you know what? Thanks to you. That's right, to you, our watcher, our listener, the person who makes Twiet possible. If it wasn't for you, we wouldn't have this Best Dang Enterprise Tech podcast. And for you, I am eternally grateful. But you know what? I want to give something back. And this is what I want to do. I want to give you each and every single episode of Twiet automatically in your device of choice. That's right. If you go right now to our show page at twit.tv/Twiet, you'll be able to find all the different ways that you can have every episode of Twiet delivered to your device in the resolution or format that you want. Each and every single week on your iPad, each and every single week on your iPod, your laptop, your Zune, your Android device. That's right, we make it because that's the kind of love we've got for our Twiet Riot. Also, did you know that we do this show live every Monday? If you stop by live.twit.tv at 12 o'clock noon, you'll be able to see how the sausage is made. You get to see all the parts that go into making the show before and after the actual recording. It's part of the experiment that is Twit TV. Also, we've got a YouTube page. If you drop by youtube.com/Twiet, you'll be able to watch not only all of our episodes, but all of the individual segments. That's right. Stuff My IT Guy Says, the Data Closet, Pro Gear, Pro Tip, all the little bits and pieces that make Twiet just that much better for the geek who wants to know about how the world is connected. Also, you can follow me on Twitter at twitter.com/PadreSJ. If you follow me, not only will I be your friend, but you'll be able to find out what I do in between shows, and you'll be able to discuss each week's topics. Tell me what you want to see. Tell me what you want to hear. Tell me who you want to hear from, and that's what we do. That's how I get the topics. That's why we're talking about Skype and Xeris today, because people ask me on Twitter. And again, that's just part of the experiment that is Twit TV. Finally, you can also drop by, if you're going to watch us live, the chat room at irc.twit.tv, where you'll be able to find some of the greatest engineers, some of the brightest people, and some of the funniest trolls. Again, why not join us and be part of the Twit family? I want to thank Cyberdog in the chat room for helping us out with the show notes, to Karsten Bondi, my super producer, to Jason, who is my TD, and, oh, by the way, Jason, I heard through the grapevine that there's a show on the Twit network all about Android, but I for the life of me, I can't figure out what it's called. Could you help me out?
Man, you were so close. All about Android. Maybe you weren't more than close. Maybe you got it 100%. All about Android, twit.tv/AAA. Check it out if you like Android or are interested in it at all.
And where can I can watch that live, right? I mean, if I wanted to see the amazing people on the show.
The strange thing is you can watch all of our content live at live.twit.tv. That's all you really need to know. Just go there and park it all day and, do your work, but not really because you're watching live. So there you go.
There you go. That about does it. I'm Father Robert Balacer, the Digital Jesuit, just reminding you, if you want to know what's going on in the enterprise, just keep quiet. Now, Hans, you got to help me here. I cannot pronounce your last name. Give it to me, and I will put a phonetic here and hopefully not completely kill it.
Within the Netherlands, we would say Osnabrugge. But if you make it Osnabrück or something like that, it's fine.
I will try. Wow. Okay. Stop laughing, Jason.
I'm not laughing.
Yeah, no, that was cheaper.
Brew, and then how does it? The last bit is Osnabrüche.
Osnabrüche. Yeah, sounds German. Yeah, sounds great.
Just like it's spelled.
Just like